we've seen indications that sine of x could be approximated by a polynomial like this. We haven't actually shown that if you continue this pattern on forever, you get exactly sine of x, but we'll have to deal with that in a later section or later chapter. Let's ask here, is this an alternating series? Well, we might have to be careful about the x's, because if some of the x's are negative, if the x is negative, that's going to throw some signs in there, so let's think about it carefully. So if x is greater than 0, then all these x terms are positive, and so none of the signs change. We just still have the positive term here, negative, positive, negative. So yes, it's alternating if the x values are greater than 0. If the x value is less than 0, then we have a negative here, and the x cubed is going to be negative, so that means we would end up with a positive here, and then we'd have a negative here, because x to the fifth is still negative if x is negative, and then we would have a negative term here. So we would still have alternating signs, but it would be negative and then positive and then negative and then positive. So if x is less than 0, yes, but it would be negative, positive, etc. Where if x is greater than 0, then it's positive, negative, positive, negative. You might be wondering, well, what if x is equal to 0? Well, then this is just all 0. It's not alternating, but it's pretty obvious that the sum converges because it's just 0 plus 0 plus 0. So we'll say if x equals 0, you get 0 plus 0 plus 0 plus dot dot dot, which we're going to call boring, don't even need the alternating series test. So it's alternating regardless of the value of x. Let's say that a sub n is like, I'm not going to say it's exactly the same as, but it's like this, like 1 over 5 factorial 5 to the n. So it's like 1 over n factorial, x to the fifth there, so x to the n. There's a little issue there with odds and evens that we'll take care of in a later section. But in particular, it's not the plus and the minus. It's just the part other than the plus and the minus here. So we're going to ask, like the alternating series test tells us to, is a sub n decreasing? So this one gets a little complicated. Let's suppose x equals 10. We would have 10 and then 1 over 3 factorial 10 cubed, which is massively bigger than 10, right? 10 cubed is 1,000 divided by 6. It's still massively bigger than 10. And then 1 over 5 factorial 10 to the fifth, which is even bigger than this. This does not look like it's decreasing. So we could say 1 over 7 factorial 10 to the seventh. That's even bigger than this was. But it turns out if we go out far enough, the factorial in the bottom overwhelms the exponential that's going on. So we need, we could graph it, and it does start increasing initially, but like these terms would, but then eventually it starts decreasing. So this axis isn't the x-axis, it's kind of like the n-axis, but again there's that kind of even and odd issue here. So we'll put the n in quotes, say it's basically the n-axis. So even for x equals 10, this does eventually start decreasing. For x equals 100, it would start decreasing even later, but it would eventually start being purely decreasing. So we can say, yes, a sub n is eventually decreasing. Because factorials grow faster than exponentials. Exponentials, like in this case it's x to the n, but n is the variable we're considering, so it's kind of a constant to a variable power. and n is treated as x is treated as constant here. So it was a long story, but ultimately we decided that a sub n is eventually decreasing, or ultimately decreasing. So that's good. And then what about so part 2 is the limit as n goes to infinity of these terms. We'll call them a sub n, but you just call them the terms. Is that equal to 0? Well, it takes, again, a little more thinking, but again, the factorial grows faster than the exponential, and so the limit is 0. So again, due to the factorial versus exponential thing. Like we talked about there. So what can we say from the alternating series test? It says this sum converges. And we had checked it at all values of x, at least thought about it. So that's pretty interesting that this sum that has powers of x that keep growing still converges no matter how big x is, or x being negative. It still doesn't show that it's actually equal to sine. Like, does the approximation get better and better? Well, we know the approximation converges. Does it converge to being the value sine of x? Again, we'll have to see that in a later chapter.